All right, so let's have a look at this review. So we're going to start with the self-test portion of the review section. So it says, show how the log of 225 plus the log of 4 minus the log of 9 can be evaluated without using a calculator. So again, you're not just going to type in your work. I'm going to need to see how you would do this type of problem on the test. So what we're going to use is those property of logarithms. Remember that if we're adding, that we multiply the values of the logarithm. Okay, so if we see that we have adding here, we're going to multiply those values. And when we see subtraction, that means we're going to divide by that value. So when I write this as a single logarithm, we could say that we would have 225 times 4, and then we divide by 9. Well, if you're to take 225 times 4 on your calculator, you're going to get 900 as your answer. So we'd have the log of 900 divided by 9. And 900 divided by 9 is 100. So we have the log of 100, which hopefully you recognize the log of 100 is 2. So that's how you would do that without a calculator. So if this was a test question, I would need to see your work. If you just wrote down 2 as your answer, I'm not going to give you complete credit for that. All right, this one. Okay, so it says use the facts that the log base 11 of 7 is approximately 0.8115, and the log base 11 of 3 is 0.4582. To estimate what the log base 11 of 7 divided by 3 would be. So again, we're going to use those properties of logarithms. Remember, if we are dividing, we can break this apart into 2 separate pieces using subtraction. So we would write this as 2 separate logarithms to say log base 11 of 7, that the log base 11 of 7 divided by 3 is the same as log base 11 of 7 minus log base 11 of 3. Well, we know log base 11 of 7 is 0.8115. And we know log base 11 of 3 is 0.4582. And now when I subtract those, you get your answer of 0.3533. And again, this is the kind of work that I would need to see shown on the test. If I just see an answer, I need to see how you got your answer very specifically. So make sure that you're used to and accustomed to showing your work. All right, number 9, it says find the solution to the nearest hundredth. Okay, so we have 6 to the x power equals 1.48. So what I notice about this is that, so this is an exponential equation, and I'm stuck. I can't do anything. So remember, there's 2 ways we could approach this problem. One would be to take the log of both sides. So if we did that, we'd have log of 6x equals the log of 1.48. But remember that x that's up as an exponent would go in front of the logarithm. So we'd have x times the log of 6 equals log of 1.48. So to solve for x, I would divide both sides by log of 6. We'd have the log of 1.48 divided by log of 6. And when you do that, you get approximately 0.22 as your answer. Now, an alternative way to do this would be just to take this and put it directly into logarithm form. Because if I'm going to put this in logarithm form, my base would be 6, my value would be 1.48, and that would equal my exponent, which is x. So if I have a TI-inspired calculator, we could just type this directly into our calculator and get 0.22 as your answer. But if you don't have a TI-inspired calculator, from here we would use a change of base theorem, which would be log of 1.48 divided by the log of 6, and then that would give you 0.22. So you can see that there's a couple different ways we could solve this problem. But again, I need to see your work and how you would solve this. I don't want to just see an answer. All right, number 14, it says use properties to write an equivalent equation that does not contain logarithms. All right, so the first thing I see is we have a couple of numbers here in front of the logarithms. So those are going to end up being exponents for the values. So we'd have the log of a to the 1/2 power plus log of b equals log of c to the 1/3 power. Okay, so we took care of the exponents. Then I see that we have addition here. So that means we can write this as a single logarithm by multiplying these 2 values. So I would say, whoops, get a pen here. So I would say that this would be equal to the log of a to the 1/2 power times b equals log of c to the 1/3 power. Now we could undo the logarithms by basically taking the inverse log of both sides. And then we would have just a to the 1/2 power times b equals c to the 1/3 power. And that is all we can do. So that would be your final answer. All right, so these we would simplify without a calculator. So for this first one, 8 to the 1/3 power means what times itself, or what's the third root of 8? So what times itself 3 times would give us 8? Well, that would just be, that would just be 2. For part B, we're going to break this up into the third root of 8 to the 5th power. Well, we just found the third root of 8 to be 2, and 2 to the 5th power would be 32. Now the next one, 8 to the negative 2/3 power, means that we would, what I like to do is I like to apply or get rid of the negative first by taking the reciprocal of the base. So that would be 1/8 to the 2/3 power. And again, you can do this in any order as far as when to apply that negative. Again, we're applying the negative in the sense that it takes the reciprocal of the base to make it positive. The base will never change to become negative. So if you said this was -8, that would be wrong. So when you have a negative exponent, we're going to, at some point, need to take the reciprocal of the base. All right, so now let's apply the 2/3. So that means that I'm going to break that up into the root and then the power. And so the third root of 1/8, well, we take the third root of both the 1 and the 8, so that's going to be 1/2. Now I would square that. So we square the 1, we square the 2, and we get 1/4. So your answer for C would be 1/4. All right, let's look at number 2. Number 2, we're going to break this up again into 2 pieces here. Now, this kind of question, when it says do it without a calculator, in the future you'd be able to use what we call like a baby calculator, which just says add, subtract, multiply, and divide. So you can see what times itself 8 times would be 256. But the fact that we're trying to figure out what times itself 8 times would be 256. 256 is a relatively small number. So that tells me that that's probably going to be 2. And if you tested it out, sure enough, 2 to the 8th power is 256. And now if I take 2 to the 7th power, well, if 2 times itself 8 times is 256, and I want to figure out what's 2 times itself 7 times, a real easy way to do that would be to go backwards once from 256, and 256 divided by 2 would be 128 in my head. That's what I do to do it without a calculator. Otherwise, you could do it the long way of taking 2 times 2 times 2 times 2 times 2 7 times and get 128. Right, now the next one, this is the same as 256 to the 1/2 power, or the square root of 256. I don't expect you to know that one, but just know that that would end up being 16. And lastly, this 256 to the 1/4 power. That's basically asking you the 4th root of 256. So what times itself 4 times is 256? Well, it's got to be bigger than 2. It's going to be an even number, and that ends up being 4. So 4 would be your answer for number 2. All right, for number 3, basically for parts A and B, they're doing this in baby steps. So I'm just going to skip to part C, because by doing part C, we're going to be doing parts A and B anyhow. I just want to make sure, because on a test, I wouldn't ask you for parts A and B. I would ask you for a problem like this. You just have to know that parts A and B is how you would get your answer. So here's a process that we would do. So the first step is we would break this up into the 5th root of 32 divided by the 5th root of 243. So we want to figure out, well, what times itself 5 times would be 32. Well, hopefully you recognize that that would be 2. Then we got to figure out what times itself 5 times would be 243. Well, 3 to the 4th power is 81. And so if I took 81 times 3, that's going to be 243s. So 3 to the 5th power would be 243. So my answer for this, that can't be reduced at all. So my answer would just be 2/3. All right, let's look at this next one. So in the next one, we have the cube root of -8. Now you might think, oh, is this going to be one of that we have to use imaginary letter I? Or is this one that's a non-real solution? Well, anytime we have an odd root of a negative number, your answer is going to be negative. So it's going to be the same as a negative cube root of 8. And the cube root of 8 would be 2, so our answer would just be -2. All right, let's look at numbers 5 and 6. So starting with number 5. So for 5a, they ask us to rewrite these using a radical sign. So remember, the denominator represents the root. So this is going to be the 5th root. The numerator represents the power. So this will be the 5th root of p cubed. And then in part B for number 5, the only part that's being that has an exponent is the r. The 2 does not apply. So the 2 is going to go on the outside of the radical. Inside the radical, we're going to have the 4th root, because that's what the denominator there is 4, of r cubed. Now, if this had been written like this, then the 2r would be underneath the radical. But because it isn't, it just means that only the r would be under the radical. All right, let's look at number 6. So for number 6a, it's q to the negative 7/3 power. Again, we're going to rewrite this using a radical sign. So the first thing I recognize is we have a negative exponent. Well, actually, we're going to leave that as a negative exponent. We're not going to. I was thinking that maybe we'd want to take the reciprocal. We don't need to do that for this one. We just want to use this as a radical sign. So I recognize that this is a cubed root. So it'd be the cubed root of q to the negative 7. Otherwise, if you wrote it as 1 over the cubed root of q to the positive 7th, I would accept that. But this technically would be the correct answer. All right, part B. Again, just like part B of number 5, this 1/6 only applies to the n. And we could write this as a fraction like this if you wanted to. So you would have the 6th root of n, or if you wrote it as 1/6, I'm sorry, this would be a 5 down here. We're dividing by 5. Or we could have 1/5 times the 6th root of n. Either one of those would be the correct answer. I think for the book, I think the book wrote it the second way, but if you wrote it the first way, that would be the same thing. All right, let's look over here at number 7. Okay, so we want to write these without a radical sign. So basically there's a couple ways that I'd let you do this one. If you wrote it like this, that would be fine. But I believe the book had it written like this. What they did is they applied that exponent to everything inside the parentheses. So then they wrote it like that. So both of those would be the correct answer. For number 8, for that one, again, we're going to write it without a radical. So I'm going to look at it this way. So we would have 1 over, so this would be m cubed n to the 5th, all raised to the 1/15th power. Now, if we don't want to have a fraction, we could say that this would be the same as m cubed n to the 5th to the negative 1/15th power, because then what that would do is that would, again, to simplify that, we would take the reciprocal of the base, which means it would be 1 over m cubed n to the 5th. But then let's just go ahead and simplify this further by distributing that exponent to everything inside of there. So if I took 3 times negative 1/15, that's going to reduce, because you'd have negative 3/15. That reduces to negative 1/5. And if I distribute that negative 1/15 to this exponent here of 5, I'd have negative 5/15, and that reduces to negative 1/3. So this one, it would be better to go ahead and distribute that exponent, so in that way we can simplify those exponents and get m to the negative 1/5 times n to the negative 1/3. All right, for numbers 10 and 11, I'm going to look at these graphically, and we can sketch a graph here. So when it says x, we're trying to find out the number of real nth roots and find all of those, what those nth roots would be. For number 10, the way that I'm going to think of this is this would be the same as x to the 8th power equals 6,561. And graphically, the way that that would look, anytime we have an even power, like if I were to break this up into 2 graphs, x to the 8th would look like this. Kind of look parabolic in a sense, but it looks more like a bucket, because the larger that even exponent gets, the more of a less rounded it becomes there at the vertex. And then y equals 6,661 would be a horizontal line, again, going through where y is 6,561. And the purpose is just helps us see how many solutions there are. So we could see that there would be 2 possible solutions. So if I were to go and solve this and take the 8th root of both sides, my calculator is only going to spit out one answer. But we need to recognize that there is actually two possible solutions. So for part A there, let's make sure it's, so for 10A, we would say that there's going to be two solutions. And so for part B, find out what those solutions are. Well, if I took the 8th root on my calculator, 6,561, I get 3 as my answer. So that means one of the solutions would be 3, but that means this one over here would be -3. So we're going to say there's two solutions, a plus and a negative on 3. So let's look at number 11. So in number 11, I'm going to look at this as being x to the 9th power equals 512. All right, so if I were to graph out just x to the 9th power, I would get this kind of twisted line, this little zigzag line here. And if I were to graph, so that would be the graph of the function there, x to the 9th power. And if I were to graph y equals 512, I'd get a horizontal line here. And that horizontal line only intersects the graph at one point. So for number 11, part A, there'd be just one solution. So to figure out what that one solution would be, we would take the 9th root of both sides. And when I take the 9th root of 512, I get 2 as my answer. It'd just be the one solution, it would just be 2, not plus or minus 2. All right, let's look at numbers 12 through 18. Let's look at number 12. So anytime the base for a logarithm, and if we have a value there that has a base with an exponent, anytime those are the same, your answer is just the exponent. Because again, the reason why is we're trying to figure out what exponent we would apply to 7 to get 7 to the 5th. Well, the exponent we'd apply to 7 would just be 5. All right, so for number 13, we're trying to figure out what exponent we'd apply to 10. Okay, so we're trying to figure out, let me do a question mark instead. We're trying to figure out what exponent we'd apply to 10 to get 0.001. Now, 0.001 is the same as 1 over 1,000. All right, so the kind of exponent that we'd apply to 10 to get 1 over 1,000 would be a negative number. Okay, so I know that that exponent has to be a negative number, because a negative would make that into a fraction, 1 over 10. And then what exponent would I apply to 10 to get 1,000? Well, that would be 10 cubed. So 10 to the negative 3rd power would be 1 over 1,000. So log base 10 of 0.001 would be -3. All right, number 14. So for this one, we're trying to figure out what exponent we'd apply to b to get 1 over b to the 4th. So just like the previous one, in order to get it to be a fraction, it's got to be negative. And then what exponent would apply to b to get 4, or b to the 4th? It would be -4. So our answer for this would be -4. Again, your answer does not include the base, because remember, we're just the logarithm. When we're dealing with trying to simplify or solve a logarithm, we're trying to look for, our answer is going to be the exponent. So it's just -4 is your answer. All right, let's look at number 15. 15 is the trickier, I would say, of this entire section. So maybe this is the one that you're waiting to look for. So we're trying to figure out what exponent we would apply to 64 to get 512. Now, that seems really difficult. So let's change this 64 to be something that's more manageable. 64 is the same as, now if you played around with the calculator, 2 to the 9th power, I'm sorry, 2 to the 6th power rather, is 64. Okay, so 2 to the 6th power is 64. And if you were to play around in your calculator, you would find that, I don't need parentheses here, you'd find out that 2 to the 9th power is 512. All right, so now I'm trying to find out what exponent would I apply to 2 to the 6th to get 2 to the 9th. So in essence, so the bases are the same, so I really don't care much about the bases. So I'm going to look at this as an equation. I'm going to look at this as 6 times some number is going to equal 9. And if I divide both sides by 6, I get 9/6. Whoops. I get 9/6, and that reduces to 3/2. And that's my answer. My answer is just 3/2. So if I were to take 64 to the 3/2 power, let's see what happens there. Well, the square root is 64, because we break that up into the root. and then the power. And the square root of 64 would be 8, and 8 cubed, if you didn't know this, which I don't expect you to know this, but just to let you know, 8 cubed would be 512. So sure enough, 64 to the 3 halves power is 512. So your answer there would be 3 halves. So that, like I said, is the hardest one. You probably won't see one like that on the test, but it is very good to make sure that you know how to do that type of problem. All right, let's look at number 16. Number 16, remember natural log is the same as log base e. So that's important to remember, because remember, if we have this base and this base being the same, your answer is the exponent. So our answer for number 16 would just be n. All right, let's look at number 18. Number 18, I'm going to change the way that this looks. So this is the same as log base m of m to the 3/6 power. And again, anytime this base and this base are the same, your answer is that exponent. So our answer for this would be 3/6. Now anytime we deal with fractions, we want to reduce those. So 3/6 reduces to 1/2. So your answer for number 18 would just be 1/2. All right, so for 19 through 22, we're solving these equations. So for number 19, the base is already by itself, and our base is e. So instead of taking the log of both sides, I'm going to take the natural log of both sides. So I'd have the natural log of e to the nth power equals the natural log of 56. Well, remember that this n that's up as an exponent would be put out in front of here. So, and the natural log of e is just 1. So we'd have n equals the natural log of 56. And if you do that on your calculator, you'd end up getting approximately 4.025 as your answer. Now another way that you could have done that same problem is you could have just skipped all that and put it directly into logarithm form. If you put this in logarithm form, you'd have a log base e, and hopefully recognize that, oh, we don't need that. Log base e is the natural log. And so we'd have the natural log of our value, which is 56, equals n. Do that on your calculator, you get your same answer. So there's 2 ways you could go about doing that one. All right, let's look at the next one. So the next one, we're going to do the same thing. I'm going to start it out the same way as I did the previous one. So we're going to take the log of both sides. I'm just going to skip. So if I take the log of both sides, we'd have 2 to the x power, but again, that x we'd put out in front, and then we'd have the log of 1 over 40. So to find what x is, you would do log of 1 over 40 divided by log of 2. When you do that on your calculator, we get approximately negative 5.322. But again, there's an alternate way that we could do this, and that's putting it in logarithm form. So our base is 2, our value is 1 over 40, and it equals our exponent, which is just x. So if you have a TI-inspired calculator, you can just put this in your calculator and get your answer. Or if you don't have a TI-inspired calculator, you can use a change of base theorem to write this as log, or you do this on your calculator as log of 1 over 40 divided by the log of 2, and that would give you the same answer. So there's a couple ways again to be able to do this type of problem. Now when we do number 21, for number 21, the base is not by itself. So before we do anything, we need to get the base by itself. So I'm going to divide both sides by 9. So we would have 4.5 to the t power equals, now 10 divided by 9 is a decimal that repeats itself, so to be more accurate, I'm just going to leave it as 10/9. All right, so now we're going to do this again by taking the log of both sides, and when I do that, the t would go out in front, so it'd be log of 4.5 equals the log of 10/9. So to find out what t is, we would divide both sides by log of 4.5. And you get your answer of, let's see, 0.070. Technically 0.07, but since they say around here is thousands, we'll just put it in as 0.070. All right, Let's look at, and by the way, too, that one you could do just like the previous ones. You could do it in a much faster way by changing it to the logarithm form, but I won't take the time to show you that since I showed you on the previous ones. All right, let's look at this last one. So for the last one, just like the one that we just did here, we need to get the base by itself. Okay, so if the base is not by itself, we need to make sure we do that. So this would be 10 to the y equals, and we'll just leave this as, to be more precise, 7 divided by 4.6. All right, so now when I go to solve this one, watch what happens. So when I take the log of both sides, we'd have the y times the log of 10 equals the log of 7 divided by 4.6. Well, the log of 10 is just 1. That's one of those you should know. So now all I have to do is take the log of 7 divided by 4.6, and when you do that, you get your value for y is approximately 0.182 is your answer. Again, we could have put that in, so we could have skipped from this step. We could have put this directly into logarithm form. So we have our base is 10, so just be the log, base 10, or just log, of our value of 7 divided by 4.6 equals our exponent, which is y. So for this one, you wouldn't have to put it into, you wouldn't have to use a change of base theorem because our base is a common log. And so then you could get directly to your answer. So again, sometimes doing it that way is a lot faster, but some students have a hard time remembering the order of how to put everything in. So if it's easier to just take the log of both sides, you could do that and always get the right answer. All right, let's look at numbers 38 through 40. So for these problems, they tell us log base 4 of 7, or log base 4 of 11 is 1.73, and that the log base 4 of 7 is 1.4. So I want to figure out how I can use that information to get log base 4 of 77. So let's start with 77. How can I use 11 and 7 to get 77? Well, hopefully you recognize that 7 times 11 is 77. And using those properties of logarithms, we would see that the log base 4 of 7 times 11 would be the same as log base 4 of 7 plus log base 4 of 11. And so now we would just add those values. So we have log base 4 of 7 is 1.40. Log base 4 of 11 is 1.73. So when you add those together, we get 3.13 as your answer. So on a test, I would need to see all of this work. I would not want to just see the answer because anybody can just type that in on their calculator. I want to make sure that you know how to use those properties. All right, looking at number 39. And by the way, on the test, it'll probably be one like on the quiz where I won't even tell you what the base is. So you won't be able to know what to type in on your calculator. So please make sure you know the process. All right, let's look at number 39. So for number 39, we have log base 4 of 121 divided by 7. Well, hopefully you recognize that that's the same as log base 4 of 11 squared over 7. And we could rewrite that now as log base 4 of 11 squared minus log base 4 of 7. And that exponent, that 2, we can put in front of that logarithm. So now, log base 4 of 11 we know is 1.73. And log base 4 of 7 is 1.40. So on my calculator, if I take 2 times 1.73 and then subtract 1.4, we end up getting 2.06 as our answer. All right, let's look at the last one there, number 40 in this section. So I'm going to rewrite that as log base 4 of 7 to the 1/14th power. So now that 1/14th we can put out in front. So it'll be 1/14th the log base 4 of 7. And they gave us the log base 4 of 7 is 1.40. So when you multiply those together, we would just get 0.1 or 0.10 or just 0.1 as your answer. All right, so for 41 to 43, we're just writing these as a single logarithm. Don't have to do any simplifying beyond that. We're just going to write this as a single logarithm. So remember, anytime we're adding, we multiply the values. So for this one, we would multiply 500 times 200. And when you do that, then you'd get 100,000. So that would be equivalent to the natural log of 100,000. So that's all you'd have to do there. For number 42, we see that we have an exponent here. So that exponent would be applied to the 20. So this would be the same as a log of 500 plus the log of 20 squared. Now we could do a couple of things here if you want. You could multiply these together, and or you could square the 20. Let's actually do that. So we would square the 20, which would be 400. And then we would multiply those two values together because we're adding. And when you multiply 500 times 400, you get 200,000. So we would have the log of 200,000. Again, you didn't have to simplify this. It didn't say simplify. It just says write it as a single logarithm. So that's all you'd have to do. All right, number 43. To write this as a single logarithm, we'd have the natural log. Since we're subtracting, this time we're going to divide those two values. So we would write this as a natural log of 100 divided by 25. Now, anytime we have a fraction, please always simplify or reduce that. And if you reduce that, 100 divided by 25 would just be 4. So that would be the same as a natural log of 4. That's all you do those three. All right, let's look at number 48. So it says, show how a log of 75 plus log of 4 minus log of 3 can be evaluated without using a calculator. So we're going to use those properties. So remember, anytime that we add, we're going to multiply the values. Anytime we subtract, we're going to divide by that value. So the way we're going to write this is we would have the log of 75 times 4 divided by 3. Now, 75, let's go ahead and simplify that. 75 times 4 would end up being 300. And 300 divided by 3 would be 100. And hopefully you recognize that, because this is a base 10, what exponent would apply to 2 to get 100? Would be 2. So your answer for 48 would just be 2. So again, you want to make sure you know how to do this without a calculator, because you will be required to show me answers like this on the test. All right, number 54, it says, rewrite as an equation that does not involve logarithms. So the first thing I'm going to do is I'm going to work on that right side. So there's really nothing I can do right now on the left side. But I see that there's a 2 there, so that's going to be an exponent for the w. All right, I can simplify this further by, since we're multiplying there, by multiplying the w squared and the 3's. So I'm going to put the 3 first. It'll be 3w squared. Now I could use the inverse log of both sides to get rid of the logarithm. So we would just have z equals 3w squared. And that's it. That's all you can do for that problem. So that would be your answer for 54. For number 55, it says the natural log of v equals 4/7 times the natural log of b minus the natural log of c. So again, we're going to write this without any logarithms. So the first thing I'm going to do is I see the left side. There's nothing I can do yet on that side. But I see that just like before, we have an exponent. Minus the natural log. Oops, I'm going to write this like this. There we go. Okay, so now since I'm subtracting, I'm going to divide those values. So we'd have the natural log of v equals natural log of b to the 4/7 divided by c. So I could take the inverse of the natural log of both sides to get rid of the natural logs. So I'd have v equals b to 4/7 power divided by c. And that's all we can do with that one for number 55. All right, lastly, let's look at the story problem. So it says a family has $16,000 saved for college tuition. They will need $64,000 for college expenses 5 years from now. If they place their money in an account with continuous compounding, what annual rate must they find to assure them of the needed $64,000? Okay, so it's time. So we're going to use PERT. How do we know that? Because we see that phrase, continuous compounding. So anytime we see that phrase, we're going to be using PERT. So A represents the total amount. The total amount is our goal, the $64,000. P represents our initial amount, our principal, which is $16,000. Our rate I'm trying to find, and we're going to need this money 5 years from now. So our time is 5. So I'm just going to say 5R. All right, so to start out with, I'm going to take and divide both sides because we want to get the base by itself. So I'm going to divide both sides by 16,000. And when we do that, we get 4. So now we get this exponential equation to solve. So one way to solve this would be to take the natural log of both sides. So we'd have the natural log of 4 equals, and then that when I take the natural log of both sides, again, this 5r would be as an exponent, but that exponent we could put out in front of there. So I just do that all in one step. So we'd have 5r times the natural log of e. The natural log of e is just 1. So now to solve for r, I'm going to divide both sides by 5. And so when you do that, you get, so the natural log of 4 divided by 5 is 0.2773. Now the key here is it says that we want to figure out the rate. So the rate is going to be as a percent. So we're going to move that decimal place over 2 places. So it'll be 27.73 as a percent. So that's going to be really hard to find any bank that would offer that kind of a percentage rate. So the likelihood of that $16,000 growing to $64,000 is pretty impossible. So they'd want to make sure that they find other ways to invest or find other ways to make some money there to make that money that they would need in 5 years. So anyhow, that is how you do the review. So hopefully that answers all the questions you have. And if not, make sure that you reach out to me so we can figure out what to do to get ready for the test.